Okay, empirical formula problem. We're also given a molecular weight. That's going to allow us to get the true formula as well. So what we'll do first is we've got these percentages for carbon 84.06% and for hydrogen 15.94%. We're going to assume we have 100 grams of compound, which means that those are also the masses present in 100 grams. So the first thing we'll do is figure out our number of moles, so 84.06 grams of C times grams of C on the bottom, moles of C on the top. 1 mole of C, 12.01 grams of carbon on the bottom. Comes out to be 7.00 moles of carbon. We've got 15.94 grams of hydrogen. Grams of hydrogen on the bottom, moles of hydrogen on top. 1 mole of hydrogen, 1.01 grams of hydrogen. That's going to come out to be 15.8 moles of hydrogen. Next thing we want to do is take each of these, divide through by the smallest one. So for carbon we'll have 7.00 moles divided by 7.00 moles. That's going to be 1, so that's for the carbon. For the hydrogen we've got 15.8 moles divided by 7.00 moles. And that's going to come out to be 2.26 for the hydrogen. Alright, so at this point here's what we've got. We've got carbon is to hydrogen, this is the mole ratios. We've got 1 is to 2.26. Now I can't just go ahead and round that to 2, it's just too far away. But what I've got to look at is look at the 0.26 and ask myself what common fraction is that closest to. And I know it's close to 0.25, so I would say that it's close to a quarter. So I would say that this could then be written as 1 is to 2 and a quarter. My next step is then to take this and try and write it as whole numbers, and I've got 2 1/4 here, so clearly what I'm going to have to do is take each of these and multiply them by 4. So I'll take that, multiply by 4, and I'm going to end up with 4 is to 9. So the empirical formula here is going to end up being C4H9. So I'll write that up here. EF equals C4H9. Now what I'm also given here is a molecular weight. This will allow me to get the true formula of the compound. So in essence what I'm going to do is I'm going to say, well, I've got 114 grams per mole here. How many of these empirical formula units can I fit into 114 grams? The easiest way of doing that is I figure out the mass of the C4H9 unit, and it's going to be 57 grams per mole, or around about 57 grams per mole. It's just from 4 carbons, which weigh about 12, and 9 hydrogens, which each weigh about 1. So what we've got here is 57 grams per mole for the empirical formula. Now what I'm going to do is I'm going to take the true formula, which is 114 grams per mole, divide by 57 grams per mole, and that's going to give me 2. So what that tells me is, let's get rid of this stuff here. What that tells me is that there's 2 of these C4H9 units in the true formula of the compound. So what I'm going to do is I'm going to take the C4H9 and multiply it by 2, and that's going to be C8H18. This comes out to be the true formula of the compound.